Great.
Welcome to today's webinar in our series on the future of AI in education and training. I'm Lewis Johnson, the host of the overall series. I'm very happy today to have Neil Heffernan from Worcester Polytechnic University join us. Neil is director of the program in Learning Science and Technologies there, and he's also leads the Assessment Project, a very interesting project which has 50,000 users currently. Regular attendees of this series know that one of the things we're talking about is the potential of data to transform learning and learning science. And that's going to be the focus of Neil's talk today. So Neil, we look forward to your presentation.
Thank you very much for inviting me. And so I'm excited to actually tell you about how we're using this platform with these 50,000 kids to do all sorts of cool science. I'll be getting to how external researchers can propose their own studies in the platform we built, because I built a lot of infrastructure to support randomization. And I'm not the only guy with ideas on how we might actually improve mathematics education. So I'll come back to that. I first got to make sure you actually understand what the basics are, what is assessments, you get more of the backstory, and then we'll actually talk about some of the current funding projects, including the ones that actually allow external researchers to propose their own studies inside of assessments. Before I leave the screen, Christina Heffernan and my wife have been doing this for about 15 years. We were both middle school teachers a billion years ago, middle school math, and so it was kind of natural for us to build a platform that we thought would actually work in our classroom. In the top left-hand corner, you'll actually see in the front row, next to Christina and I, Andrew Burnett, one of our chief teacher trainers, our software engineer, our lead software engineer, David Magid, another teacher, Eric Van Nugent, and a bunch of PhD students in the back rows. They're helping us build this stuff. So you're right. So I'm a professor at Worcester Polytechnic Institute. In fact, I was born in this town, Worcester, Massachusetts. I'm the director of the Learning Science and Technologies graduate program. If you want to really learn how to say Worcester, like you lived here, it's Worcester, but not Worcestershire. Anyways, I've done a lot of peer-reviewed data mining studies, but I'm really proud of our studies of that only maybe 2 dozen of them, where we have well-done peer-reviewed randomized controlled trials. I'm going to tell you about Assessments has just been exposed to a big, huge randomized controlled trial. That is the big, huge intervention. But I also use this platform to do all sorts of small studies. And I used to do that myself, but now we let other people contribute. Where did I come from? Aside from being a Worcester boy, I went when I was doing Teach for America, and I met my wife teaching middle school math in Baltimore. I was doing Teach for America. She was a returned Peace Corps volunteer. In fact, she took my job, but that's for a longer webinar. But we were both teaching math. I got into the PhD program, and I went and started with my advisors, Ken Kadinger and John Anderson, in computer science. And ever since, I've been a professor at WPI. And Ken was the one that coined the term assessments assistance. And then what's that? What does that word mean? Let's break it apart. It's instructional assistance and assessment. And by that, we mean instructional assistance, helping kids learn while they go. And the assessment part, the MENTS, is really this tiny bit, which is we want to get teachers to know stuff. We want to help teachers know, was that lesson effective? What happened in last night's homework? You shouldn't be predicting state test scores and stuff like that. That's not what we're any good at. In fact, we're an awful testing environment. We don't have teachers that want to use assessments to give tests per se, because it's really about daily classwork and nightly homework. And I give this away as a free public service of Worcester Polytechnic Institute. And I just have to say that because I've been to math conferences and they're like, oh, it's free. They're like, yeah, there must be some hitch. No, there's no hitch. There's no catch. We give this away for free. And to be honest, one of the reasons why we get all this scientific funding, about $25 million in scientific funding, is because we do have a free service with all these students. So I built my system as a reaction to the intelligent tutoring system stuff that I've seen come out. Ken Kadinger built with a bunch of colleagues at Carnegie Mellon, including John Anderson, actually what was then called actually the Cognitive Tutor. I think it's now called Mathia, but sold by Carnegie Learning. And so I think actually people building intelligent tutoring systems sometimes actually have the vision that because a child, if a child has learned something, we should let them go on and learn something new. It sounds like an intuitive idea. And when I tell people I don't think that's a good idea, people sometimes are surprised. Even though I teach artificial intelligence, I think actually we have a different scheme by which we can actually help build slightly smarter educational technology. And I never call my stuff intelligent tutoring systems. It gives the teachers the wrong idea of what we do. I like to say slightly smarter or less dumb educational technology, because all of it's pretty dumb. It's just a point of fact. The computers are not having interesting conversations actually with the children. That's not what we're after. We're just trying to actually help them achieve greater knowledge. My big goal in life is to help lower knowledge students. And in particular, there's reason to believe actually that some of these educational technologies can actually make the persistent achievement gaps that we have in America, and those are between black and white and rich and poor. We want to make sure we develop technology that actually helps close achievement gaps, not exacerbate them. As Lewis said, about 50,000 kids actually are using assessments. I think actually 500,000 children have ever used assessments, but in a given year, right now, I think we're about 50,000. I think 12 million problems were solved last year. I get funding from actually the U.S. Department of Education and the National Science Foundation, among others, including like the Schmidt Foundation and others. And so I should probably update the slide and have others, but those two actually have accounted for 90% of the funds. Anyways, each dot on this map actually represents a teacher using assessments. As you can see, if you didn't know where Worcester was, you could probably guess from this map, because we're like right in the middle of where all the dots are. Was spread a lot by word of mouth. So what is assessments? It's feedback for students. That is actually students actually get feedback as they go. Here's a picture of if they're using their iPad or whatnot. We're just a web service, so it works on an iPad, and of course we have an iOS app and an Android app. Kids get feedback whether they're doing it in class or for home. Teachers get feedback, like Aaron brought us, showing the item report actually is what we call this thing. So he can actually share with his kids what's happening. Aaron brought us this really cool teacher. He was using my system in a way different than anybody else. When he wanted to go over homework, all the kids got feedback while they were already doing their homework, and he instead would write a question that was similar to what was on last night's homework, and then give that out while he's going around. That's kind of the bell ringer, as it is, at the very beginning of the class while he's doing roll. And that way he can see, which problems were hard last night, and do they now get it? In which case, we don't need to talk more about that. But if we still got half the kids struggling, then we should talk about that. Aaron was a really cool guy. We brought him down. We brought him down to the U.S. Department of Education and actually helped us brief stuff. So let me actually set up. We actually, I did a randomized control trial with a teacher named Kim Kelly, or Kim Thinepoint at the time, and I'm going to show you her data in a second. And I'm going to show you, you can think of it as a before and after, before assessments and after assessments, though we actually did a randomized control trial where actually half the children were actually pulled out of the room, and so that we could run one condition versus the other. That is, the two different conditions are how teachers go over homework. Let me show you what we think of as the business as usual condition, which all of you experienced as if you were born in America, or you were probably born anywhere. You probably got feedback by a teacher putting the answers on the board.
Nope, take out your homework from last night. Here are the answers.
So this is a boring video. I'm going to actually stop it. It takes 8 minutes actually for a homework review to happen. It takes 2 minutes before anything interesting happens, and I don't want to force you to actually listen to that. Eventually someone says, hey, I have a question on question number 5. When I was a middle school teacher, I did something exactly like this because I didn't have the assessment technology that I built. Now let me show you what actually it looks like when using assessments. And that is the teacher's going to pull up her item report.
Okay, so we're going to go over your homework from last night if you want to get out your sheet. A couple questions I noticed we did pretty poorly on. First question we're going to look at is this one here. 3 to the negative second times 3 to the negative 8. Common wrong answer was 1 over 9 to the 10th. What's wrong with 1 over 9 to the 10th? Yeah, what?
I get super excited that 26 seconds into math class, actually interesting conversations are happening that half of the kids made the same error. And you should talk about that. I would have died to have this information as a math teacher, okay? I could have surveyed the kids, raise your hand, how many of you got this question right? And I kind of did something like that, but boy, my lesson could have been so much more effective if I knew that all ahead of time. And also, of course, the kids getting feedback as they go. In this little video, the next question is actually basically just like it, and they're up to 61%. The video is covering the next one, which is 80%, where there's like 3 questions in a row. So kids are learning on their homework, actually, if they're getting feedback as they go. So does it work? There's a lot of things funded by the U.S. Department of Education, and 90% of interventions actually that have been funded by the U.S. Department of Education that have resulted in a well-done randomized control trial in RCT. Actually, only 11%, only 11 actually had positive effects. Like there's like a 10% hit rate. Most ideas don't really work out to lead to positive and meaningful actually results, according to John Barron in this book by Ron Haskins, Show Me the Evidence. The person in the figure is actually Jeremy Rochelle. I'm going to tell you a little bit about him. Jeremy and I wrote a grant where we actually highlighted the work by Sternberg, Hu, and Cooper. Cooper is the guy that's actually done all the meta-analysis. He's the dean of meta-analysis. In his postdoc, Sternberg and Hu actually did this nice study where they looked at the 26 actually studies that have actually been done on intelligent tutoring systems, and they report the effects of these intelligent tutoring systems are small to modest and might actually contribute to the achievement gap. They might be making it worse for actually differences between high knowledge and low knowledge type kids, or between black and white. That's what we mean by achievement gaps. So it's possible that we could be building technologies that actually only help actually the most motivated. When I think of stuff like a MOOC, a massively online open course, kids that are really motivated can go learn this all by themselves. But I think most normal kids need real humans, like we call them teachers, and that's what I used to be, to actually provide almost all the motivation and accountability. And I think that's super important. So my goal is, how do we build technology that actually helps not just educate the kid, but actually that the teacher can control. So the Waterworks Clearinghouse actually is actually the one place you should go to find out actually whether actually an intervention is actually proven to be reliably positive. And the number of interventions actually in mathematics is actually 6. We know of 6 proven things that work in this country. I am about to be number 7. In fact, I got a call an hour ago on this topic, and we are now number 7. Thank you, Louis. It was an exciting moment because my wife and I have spent a decade actually building this stuff, and we just got noticed, and this is the first public release of that. So, okay, so what is assistance? You don't know why I'm so happy, because I've spent a year building this thing. About 8 years ago, I think it was, maybe 9 years ago, I was at a U.S. Department of Education meeting, and I found out that Governor Angus King, then Governor Angus King, bought 7th graders and 8th graders a laptop and demanded the district send them home. And I immediately called my wife and was like, we're going to go run a study in Maine, because that is a great place to run a randomized control trial, because the control group also has technology. And it turns out math scores, after buying these laptops, math scores were flat for like 8 years until we came along and we wanted to do something. And it turns out we did. 44 schools. I went around and sweet-talked actually a bunch of superintendents to say, you need to agree to actually a medical quality drug trial. We're going to randomize you, and you're either going to get assessments now or you're going to have to wait 2 years. Some schools didn't want to do that, but the schools that actually wanted to sign up, actually we handed those schools off to SRI, that Jeremy Rochelle guy that I mentioned before. He was the principal investigator. We wrote this grant. Jeremy's team actually took all the schools, put them into pairs of schools, and then randomized it as, by similar demographics, because you don't want actually all the rural, all the urban schools in Maine, and there's only 3 urban areas, Lewiston, Portland, and Bangor, to be all in the same condition. So you pair them and then randomize within a pair. That's what SRI did. They randomized them according to whether they got the existing methods. That is, you can think of it, it's a business as usual condition. All the teachers already had laptops. They were already doing stuff. But this icon, this picture is meant to represent the teacher doesn't know what happened last night. So she walks in blind every morning the way I did. The assessments condition, the ones that were randomized over there to the right, actually the teacher knows what actually she wants to go over, or at least if she's looking at a report, she can. And we have a lot of evidence to suggest that actually they did. But let me tell you what the intervention looks like. So our main thing is when you're trying to get teachers to actually agree to a big randomized control trial, we had to say, you have to almost change nothing. You can continue to use whatever book you're using, okay? In fact, actually, we used actually these books. We had work study students put the answers in for every one of these books that was used in the state of Maine, and we didn't want to actually get sued by the publishers. And so here's some book actually. A kid sees this on their screen. Open your book to page 48 and go solve problem 20. So when the teacher, I used to put up on the board, I want you to do the evens tonight on page 152. We make it really easy for the teacher to log in and actually assign, I want to do the evens on page 152. So that's how book work works. The second actually thing that actually was done a lot, I think by 60% of teachers, is skill builders. Skill builders give you practice until you get 3 right in a row. And here's where we actually have what you might call an intelligent tutoring system, because kids get feedback and they get hint messages and we'll break problems down into steps. But fundamentally, we had about 300 skill builders. Teachers would assign on average maybe 40 or 50 of these. And they'd check the next morning, they'd check the report to see, hey, who exceeded the daily limit? They want to know, and here, notice how this is anonymized. We make it really easy for teachers to anonymize this stuff because they want to show it to kids so that the kids know I'm actually paying attention. At the same time, the first kid actually got a check. He solved the problem. It took him 9 minutes. He actually took 3 problems, so this kid got 3 right in a row right away. Where the second kid here, whose name was obviously obscured, and we want to show the kid's name, the teacher can go click on that. They exceeded the daily limit. My wife and I refuse to actually allow a self-pacing system. We don't want a kid, a boy or a girl going home and doing 50 items until they actually like bang their head against the wall. If you cannot actually get 3 right in a row within 10 problems, we stop you. We say, go talk to your teacher. That's enough for today. We don't want to torture you. By the way, every computer system will eventually fail. They don't actually teach everyone. And I think it's really important as a designer to build in your system a scheme by which actually teachers can then know when to intervene. I have a whole grant on actually this topic. Most companies don't want to tell you about actually their systems aren't perfect, but just the computer will go. But there's always going to be problems, and no computer system can be perfect. Anyway, back to Jeremy and Rochelle. This is Jeremy and Rochelle. I guess I should have done some drum roll. Blah. Okay, 4 years happens. Jeremy's presenting at the White House in 2016 in October in the Indian Treaty Room, and he actually spends 9 minutes revealing actually the study results that just were accepted into what we're showing us this morning, or at least I got notified about it. I got a phone call. Anyways, what did Jeremy find? Well, here's the paper. You should all read it and cite it. Online mathematics actually increases student achievement. It's actually, top left is Mingyu Fang. That's the second author. Third author, Robert Murphy, and Craig Mason at the University of Maine were the other authors. What were the 3 main findings? Well, you can read the abstract, but I'll just tell you the results. Finding 1, reliably change teachers' practices, meaning we studied actually how teachers go over homework, and teachers actually, they still spend time going over homework, but now they're focused on actually what are the hard questions and what are the common wrong answers. Secondly, that wind up driving actually an almost doubling of student learning. Go read the paper, and it's somewhere between 70% improved student learning to maybe a full year worth of instruction. A big meaningful thing on average. We were using the term Jeremy Rochelle at SRI They chose to use McGraw-Hill's Terra Nova test, which is a standardized instrument. I'd never seen the instrument before in my life, and only saw it actually after the fact. And they went and used the standardized instrument and actually found these big gains. But what actually my wife and I are super excited about is we looked to see, did we actually exacerbate achievement gains between actually the rich and poor, or high knowledge and low knowledge? In this, in Maine, there's actually not much of actually a gap between black and white, just because there's almost, well, you can't measure it because actually Maine is a very actually white place with not actually a lot of African Americans. So what we could look at though is differences between actually better prepared kids versus not so better prepared kids. We did a median split on their 6th grade, actually I shouldn't say we, Jeremy Rochelle and team, my name is not on that paper. Jeremy Rochelle did this median split actually on their 6th grade math test scores, and actually finds a big whopping difference. This little green bar, it looks small. It's actually well over a doubling of student learning above and beyond what you would normally expect in a given year. And though there's still actually a 40% improvement above and beyond what you would expect. So basically, instead of learning 1 year's worth of instruction, you're learning about 3 or 4 extra months of actually learning, even for the high knowledge kids. So we could, of course, actually close achievement gaps by developing interventions that just slow down the high knowledge kids. But that would be cheap, right? That's not what we actually want. So I'm super excited that we actually close achievement gaps. More recently, MIT actually did a killer review. They reviewed actually 2 big things. They reviewed something like 20 plus actually studies where they gave out randomized control trials that gave out either hardware, like the study that was done in Maine, except Governor King did not run a randomized control trial. He didn't give it out to randomly half the districts. It would have been better if he did, because then it would have actually had better data to find out, does it actually cause differences? But we'll forgive him for that. So anyways, just giving out hardware or giving out internet access doesn't actually mean anything. But the MIT Property Action Lab then went on to actually analyze 26, something on the order of 20 studies that actually are EdTech solutions. They wound up actually highlighting us as one of the 2 most promising interventions in the United States. I think they called us something like a low-touch actually intervention, because it is so low-touch. Like, we didn't actually hardly change what they were doing. They were still using the same books. Yeah, fine, if they wanted to use our skill builders, that was kind of new. But it wasn't like, let's retrain the teaching force or teach them all a lot of new math or some new way of teaching. Our intervention was pretty simple, which is also why 70% of teachers, 3 years after randomization, are still voluntarily using the system. So I see plenty of actually systems where some researcher comes in, does something, and then they're like, once the researcher's out the door, thank you very much, we'll go back to business as usual. But that's not what's happened with the systems. So, but I want to say, what is the systems not? So it's not like actually these self-paced systems like actually McGraw-Hill's Alex, Carnegie Learning's system built by actually my advisor, IXL or Khan Academy. I just was listening to Khan Academy actually, Saul Khan himself actually on some podcast actually going on about actually mastery learning, as if like that's the only thing we care about. Meaning, if the only thing you care about is actually building the system that actually is in charge of everything, then that's, I guess, great. But I think what's really important is teachers need to feel like they're in control. Teachers were in control in our intervention. They pick which items to give out on their homework. They pick when to assign a given skill builder. I've actually walked into many classrooms, either in using Alex or McGraw-Hill or Reasoning Mind is another one of these ones, where I've gone in these classrooms where the technology firm is telling them, oh, bring your kids to the computer lab and actually sit them in front of the computers, actually 2 days a week. And you walk in and actually, some kids are in chapter 3 of the kind of the content, and some are in chapter 23. The teacher just taught chapter 11. The teacher actually, maybe chapter 11 is quadratic equations. They want actually them practicing quadratic equations, and it's quite reasonable that they should. But the technology isn't built for that. In the Carnegie Learning System, actually a teacher, if she wants them to go practice quadratics, she actually has to artificially promote the child to the the 11th, what is it, chapter 11, I think I just said, on quadratics. But the computer is not smart enough to kind of recognize, oh, there's some topics that they still don't know and come back to. It was designed improperly, in my opinion. And we need to design a system that is not just student-focused and student-facing, but is actually a tool that the teacher actually can control. Our goal is to actually help make the teacher be a better teacher. I'm hoping that actually by getting teachers to look at actually common wrong answers and things like that, if the internet went out next year, teachers that were using assessments are still better. I don't have any proof for that. Actually, I've never told them and run a randomized control trial and taken away assessments for half of them, but that would actually be a test of that, I suppose. So where does this lead us? So the big thing that is actually happening, this kind of perfect storm in my head, is free textbooks are coming out. On this slide is names of actually them. They sometimes Engage New York, Eureka Math, and Unbound Education are kind of actually giving out the stuff that was created for free and given away under a Creative Commons license through New York's Race to the Top, which is why it's called Engage New York. Illustrative Mathematics also actually getting kind of popularized as open up resources. Is a second actually textbook series. Utah Math is a third open one. These are all Creative Commons. That means that we can take the questions, put them into assessments. And then we can also learn, hey, let's write feedback messages for those same questions. So free textbooks, one big thing. Second big thing is Google Classroom. Google Classroom is now the single most popular learner management system, and we've done a killer integration with Google Classroom. So from my research perspective, I am all about crowdsourcing. I'm trying to crowdsource from teachers, from students, and from researchers. So I have a bunch of grants like Driver's Seat, where we're actually taking open educational resources, OER, that's the label there, and Google Classroom, mixing them together. So we have some projects that I'll share a little bit more in detail in a minute. But so we have some ideas about crowdsourcing for teachers. We have ideas about crowdsourcing from students. If students can actually help each other, right now, if a kid is helping another kid, we call that cheating. But I actually wrote a grant for ONR that's the Office of Naval Research, because they actually see the value proposition in crowdsourcing. Crowdsourcing is a weird term if you haven't heard it, but Wikipedia is a type of crowdsourcing, right? We're getting the crowds to go write the encyclopedia entries. So we can crowdsource ideas from teachers. We can crowdsource ideas from students. We can crowdsource ideas from researchers. Researchers have the nice property that actually they want to come and they say, hey, I want to compare this one variable change, because that's what researchers do. They modify one variable at a time. And when they do that, I also want to run a third condition that is our best condition so far. That's our control condition. The researchers, they really care about actually comparing the two conditions that differ by one factor, and they get excited about that, and they can go write their paper. I'll show you a paper or two that actually done by researchers that will not have my name on it. By the way, if both of their conditions are worse than our current condition, when they're done running their little study, I say, thank you very much, actually, and maybe I don't invite them back. If actually they're still losing to the best condition we have so far, because I also want to actually keep giving out good stuff to kids. And I do want to actually help the research community that I am a member of actually learn what is effective, because I think we don't know. There's a lot of buzz out there on personalized learning, and these companies tell you that actually we figured out how to do personalization, and I'm here to tell you the emperor has no clothes. We have almost and I've done a lot of these randomized control trials. Even myself, we're just scratching the surface and learning what we should do for different people in different contexts. I'll tell you actually, so there's this one NSF grant I have that's actually under this DIBS program that allows any researcher to come with an idea. And if you actually want to come and you have actually an idea that actually requires us to do some programming for you, Candace Walkington and Aaron Otmar are two people that actually saw, hey, let's use your platform, Neil, to actually do experimentation, because you built a platform to do all that. So I'll tell you a little bit more about that. But I want to come back to teachers for a second, because I really got started when I saw this guy, Mr. Chris Lesage. Mr. Lesage was teaching in Gorham, Maine, and my teacher trainer actually said, Neil, you got to meet Chris. He actually, he wrote feedback messages for every question in his textbook. And I'm like, no. right? And he's like, yeah. So this is the picture of me meeting Chris actually for the first time, and he's showing me what he did. So this guy loves his kids so much that he goes home every night and actually looks at actually all the questions he gives, and then writes a tiny little text message or maybe a little YouTube video. He kind of like, he's like, it's not only Saul Khan that can put himself on YouTube and explain something, I can do that. I was too dumb to think that anyone would ever do that. So my platform actually didn't allow other teachers using Chris's book that he was using. That was one of those 20-odd books that I showed you screenshots of a second ago. And he was using some book that was like 8 years old, and no one, there was like, I think one other teacher using it. But that other teacher couldn't see and review Mr. Lucige's feedback and decide to adopt it. The ONR grant, the Office of Naval Research grant that I got actually is allowing me to actually, we built out infrastructure, and we are doing this project that we call Teacher Assist. Let me give you an example of a Teacher Assist. Here, I'll give you an example of a teacher-created feedback message for a common wrong answer. I'm going to actually hit play here.
For the student to get tutoring on this problem, they need to type in the common wrong answer. When they click submit, the video will pop up. Looks like you made a mistake on this problem, but here's what I think you did wrong. I think you multiplied on both sides by a -8. Unfortunately, that's not going to get you the correct answer. You've got a positive 72. What you should be doing is multiplying on both sides by a positive 8 to get the correct answer. Finish that problem up and you'll have the correct answer. Good luck.
So Andrew Burnett is one of the guys that is actually is now actually on this actually Teacher Assist project, where we're actually crowdsourcing from I think 8 different teachers right now. We're actually paying them a little money to sit down actually and do what Chris Luciege did for free, and then we're going to review them a little bit because I don't want to put out actually I don't want to just take anybody's stuff and actually send it out actually to go viral. But then we're trying to learn which teachers' messages to give to which types of kids. Our goal is not to figure out which teacher is better than which teacher. It's actually, because I presume that actually for some kids, maybe Andrew Burnett's going to work really well, and for other kids, actually a different type of actually strategy, a different type of teacher. And I don't know, is it important that actually Andrew's white actually, or do we need a teacher that is actually black? Maybe we're going to be able to find that out. Maybe that's not what's important. Maybe it's actually the strategy that actually he's teaching. There's a lot of things we don't know and that we need to actually go study. So I actually, my goal is to be Jimmy Wales. Jimmy Wales was the guy that created the Wikimedia platform. Okay, he didn't write any of the encyclopedia entries that we call Wikipedia, but we all kind of know Wikipedia is this amazing resource. Most people have never actually logged on and bothered to actually try to write an encyclopedia entry inside Wikipedia. I've done it enough to kind of know that's a kind of a cool platform. But one thing actually Jimmy Wales doesn't have is he doesn't actually have an ability to learn, hey, if a contribution has been made. Different authors are kind of arguing with each other on these talk pages, and sometimes the last man standing is what's happening. The person that actually last edited is what is left. And that's probably not how we're going to actually, how we should be giving out stuff in real teachers' classrooms across America. Luckily, we have a better idea. We actually can take that idea of crowdsourcing, but actually fund a small number of teachers, like my driver's seat teachers, to write feedback that we kind of know meets at least some level of quality, and then start experimenting. But one thing that I'm actually very excited about Wikipedia, and it also explains why my wife and I have to give this system away for free, is that no one would contribute to Wikipedia if they thought Jimmy Wales was selling the text actually to Encyclopedia Britannica or a World Book, right? So it's really important for us to actually make sure we give away this resource for free to everyone. Luckily, I'm a full tenured professor and I get paid just fine, and I don't need to go try to make a company out of actually this technology. And that's what my wife and I have decided to do. Probably doesn't hurt that actually I also got a cancerous brain tumor. Actually, in 1997, I was told I had 2 to 3 years to live, and my wife and I decided we should actually go for fame, not fortune. And so I guess those 2 reasons together make sense on why we're doing this. So A/B testing is actually what we're talking about. We want to compare actually different pieces of content, different hit messages, different actually feedback messages for common wrong answers. In the industry, it's called A/B testing. If you don't know much about A/B testing, you probably know Google and Microsoft and Facebook, they're experimenting on everyone. And that's true. And you shouldn't be worried about it so much. That's how the products are getting better over time. And so Microsoft spent lots of time figuring out what is the right color of blue to actually maximize their ad revenues, okay? I don't care about actually that. I care about, though, using A/B testing or randomized control trials is the exact same thing to actually try to figure out how to actually improve the content that we're giving out and ultimately improve the whole user experience for teachers and kids. So I now want to get to the point of actually let's crowdsource from actually from researchers. So I want to break out of this and actually go to actually my homepage. So if you come to my homepage, you'll see the funded projects we actually have right now. That's David Maggott, our chief software engineer. We're excited about something. So I told you about Teacher Assist, which is funded by ONR. We have some other projects that are going on that are actually more of a natural language processing actually component. And those are kind of cool, but I'm not going to focus my time there. I want to actually, these 4 grants are actually helping us make assessments better. We have a bunch of other grants that are just helping us test assessments at a bigger scale. This efficacy trial down here is a big study to test to see, can we do exactly what we did in Maine, but in North Carolina? I already told you North Carolina. I already told you Maine doesn't actually have a lot of African Americans. It's rather rural, and it doesn't really represent the whole United States. So we were able to be funded to actually test to see in a single state that is most representative of the nation. If you want to find the most representative state in the nation that actually has a good mix of Hispanics and African Americans, rural, urban, and all that, North Carolina is it. So Meng-Yu Fang and Bob Murphy, those are the 2 people that were on the original study, actually are now funded to run the efficacy trial. We have a bunch of schools right now, I think 55 or something, that are actually already been randomized to control and treatment, and we will find out maybe in about a year, actually, or 2, what the results are of that. The effectiveness trial is actually another layer up, which is actually, instead of actually, we sent actually a math coach to teachers' classrooms in Maine 3 times a year. That's an expense, sending a real human to a real classroom to actually help do that. So in the effectiveness trial, we're trying something different. What if we actually just have 3 meetings only by Google Hangout, kind of like this webinar, right? Where actually, except it's interactive, and this webinar is interactive between Lewis and I, but not anybody else. But if you put the teacher and their coach together online, basically, that's what's happening. Kirk, actually, Walter's demand on the right is the principal investigator on that. Again, these studies are run externally by someone else. I'm, of course, part of it, but you can trust they're a lot more trustworthy if someone else is running the thing. Anyways, the eTrials testbed is actually funded by NSF, and if you're interested in proposing a study, what do you have to do? You have to start with a research idea. You have to create a problem set. You have to deliver it to students and teachers, which mainly means you give it to us so we can actually expose it to actually real kids. Then you actually get data, you analyze it, and you go write up your study. Let me actually give you an example of that, and then I'll come back to the Walkington and Otmar versions. So eTrials, go here. This is our new website. It's much prettier than the one I just showed you on the PowerPoint. And in here we actually have the whole research project process. But I want to just scroll down and cut to the chase. Here's 5 papers that have come out of the National Science Foundation funding. So Emily Fife was the first lady that actually ran her own study. You will notice my name is not on this study. Okay, she actually had an hypothesis about actually how to optimize student feedback. It sounded actually plausible to me. It just so happens I was actually good friends with her advisor at the time when she was a graduate student. And so I was like, Emily, you should, she actually believed my thing. I'm going to let random people actually run studies in my platform. And so her advisor said, that Neil guy, he's not full of it. You should go take a look at it. Anyways, when you go read the study, she'll be thanking assessments as the platform delivered it, but she had her own ideas. Clinton actually, Candace Walkington, Virginia Clinton, and actually Anthony Sparks is another study. You'll notice again, my name is not on it. I was funded by NSF, so of course I collected money from NSF to actually try to take my platform and let other people do it. Candace Walkington and Virginia Clinton, their ideas are about, they've done a lot of work that suggests that actually, if you make this math problems kids are working on actually more relevant to them, maybe they actually will try harder. Candace had a lot of actually data from actually small scale, essentially lab studies that kind of show this is a good idea. Putting into the math problems actually the names of your favorite pizza parlor might actually increase motivation. But Candace was like, I got a better idea. Let's actually get kids to actually figure out how, and there's these other ones. I want to go back to this. Cordis, there's another cognitive science paper that these people did. I'm not, you can go read actually their cognitive science paper that just came out last year. But I want to come back to Walkington, because she did this randomized control trial with me. But if you remember, I told you, oh, we've also done a slightly different version. Candace Walkington was like, we have these VOTEC schools across America, these vocational high schools that actually have different actually areas, plumbing or cosmetology or health or actually auto shop. And your typical VOTEC actually classroom is doing VOTEC stuff like kind of during the week, and then the next week they're back doing math class. What if we actually made it so that the kids that were doing math, auto shop, their math questions were all actually in kind of all the story problems are all about actually auto repair, and the cosmetology students actually there's about actually running your own beauty salon and whatnot. So Candace Walkington also wanted to actually get kids to be writing problems. And I was like, we don't allow kids to write problems. We don't have technology that allows kids to write problems. So Candace was like, well, will you join me? And so I get actually 1/3 of the budget of this $1 million to actually add to the assessments infrastructure the ability for kids to write their own questions. She's got her own idea about this. I hope it works out well. I think it should be cool. In one sense, I don't really care because I'm trying to divorce myself. It's not my idea. Erin Armar's actually another person who is using assessments to actually run her own platform. She's got a really cool idea called actually From Here to There. Actually, it's all about actually graspable actually mathematics. Here's a screenshot of it, and kids can grab these equations and move them around. I think it's wicked cool. I helped hire Erin Otmar at my actually university, so I think actually it's probably a great idea. But again, it's not my idea. It's her idea, and I was just chatting actually last night. Last night, actually, the results came out, and my 18-year-old and 15-year-old were showing me we actually, for the first time, humanity can now look and see a black hole. It's actually massively impressive. We saw the 200 or so researchers that actually did this with this huge shared scientific instrument, okay, called the I forget what it's called. This cool telescope, this radio telescope type thing, actually.
A bunch of telescopes working together.
Yeah, like 12 different telescopes, like one in the South Pole. It's like absolutely amazing, right? It's a shared scientific instrument. I actually view e-trials as this shared scientific instrument. When the Hubble Space Telescope goes up, actually, the guy that built the Hubble Space Telescope, he doesn't get to decide where to point it. It's a group of scientists that actually do peer review to figure out how should we use this shared scientific instrument. So I'm super excited about trying to actually use these platforms to do science. I should show off from the inside, what does the systems look like, and how does actually an experiment actually even happen? So let me actually try to actually go live. I'm gonna, of course, demos are dangerous. I'm gonna live dangerously and actually see if the internet gods actually are gonna actually be nice to me. So let's log in and let's see if I can actually screen share, and also assistants, we can log in at the same time. So I've logged in to Miss Kelly's account. That's the lady that I showed you before. Back in 2011, 2012, she actually was the one that actually was using assessments. These are all her assignments, and I'm going to scroll down to an assignment that actually where I showed you the video that was collected. And here it is. We actually had two We had one negative exponents and negative exponents test. Test is when they actually were in test mode. They actually didn't get feedback. I'll open that, and I'll also open this one. You also see that this teacher gave a lot of skill builders, and I could show you a skill builder actually as well, because Ms. Kelly does both of those things that were done in the big study in Maine. Here's the control condition. These 3 items, and I'm going to scroll down and show you actually the exact content, view problems. And I'm going to try to make this big so you can see. The first 3 problems were really easy. They were all roughly the same. The next 3 problems were where they had to multiply exponents. See this, and this, and this. So kids could learn inside assessments if they actually got feedback. Let me scroll up here and show you the first 3 items everyone gets right, because those were easy. But the next 3, they weren't so easy. 61, 61, 66. Not a lot of learning going on. Still, 46% of kids, common wrong answer was 1 over 9 to the 10th. That's what she said in the video, if you have good recollection of that, or scroll back on this webinar. And in the experimental condition, she actually has 27, 61, 84. So kids get there. They wind up learning a lot more actually on their homework because they're getting feedback as they go. You still actually have these common wrong answers. And, you see kids, some kids, they messed up the first one, but then actually they learn from it. That's the whole point. But if you go back to the control condition, you'll have plenty of kids that if they got the first one wrong, they got the next 3 wrong. This is kind of weird. The kid got the first 2 wrong, and then they got the 3rd one wrong. Kids were not getting feedback inside of this. I failed to mention this. In this control condition, we had kids log on, and actually kids were just getting told, thank you for your input. So it's actually kind of surprising that they learned it all. Most of the time, they didn't really learn. They either got them right or they got them wrong. So let me actually also show you actually, oh, right. So, by the way, Miss Kelly also wrote her own feedback. See this little feedback button? This feedback button actually allows the teacher to write a feedback message like that Andrew Burnett guy. Maybe I didn't name him. That guy that actually wrote a feedback message. You can say, oh, it looks like, find your product actually using only positive exponents. So they're supposed to actually say, what is this? Something like actually 1 over actually 5 to the 3rd, raised to the 3rd power. That's the right answer. But a good message would be, let's look at that common wrong answer. I'm going to cancel out here. The common wrong answer is they multiplied the bases. This is exactly what was done over here. If you remember what was talked about, the kids were actually supposed to add the exponents, but actually leave the base alone. Anyways, I don't want to get down in the weeds there. I want to show you this other thing that actually the teacher can do. So I told you that people can insert experiments inside assessments. How do actually teachers wind up finding about that? So I'll show you content to assign. They come into not the assignments, into content to assign, and where they find this content. And so inside here, they can actually see, and I'm going to show you, some of these, not the problem sets I built, but actually of the problem sets, that actually, inside mathematics, they actually have these skill builders. And so we go into our skill builders and we open up this folder. Let's open up into this folder, go into 7th grade, and we'll see some of these, say, in number sense, you'll see little EXs on this. This one doesn't have an experiment, but this one does. See this little X? We're running some experiments. We have 100 experiments running right now. Multiplying integers, there's some study actually happening there. Every time a teacher actually assigns a problem set here, if they assign this, then actually more data is collected for that study. Once we find out if that study is good or bad, then we actually turn that study off and actually ask for the next study to be run on multiplying integers. And I'm hoping actually the best thing that's been found then beats our current best condition. I recognize I have 1 minute left. I guess actually to just wrap up, I'm excited to actually figure out actually how to work with others, and I invite people that want to run a study to visit actually the assessments testbed and actually explore this. But I think I should actually stop now and ask for questions.
Great, thanks, Neil. And audience, you got questions, type them in the chat window and we'll be happy to discuss them. So, very interesting stuff. I'm curious about how assessments got to where it is today. You provided that, you know, this evidence that it works, but I have to imagine there were some things along the way that didn't work, or ideas that you thought would pan out that didn't pan out. You kind of had to revise that. Could you tell us a few war stories?
Yeah, we've had many failures. Dr. Heffernan, to speak of myself in the third person, has lots of ideas. And this other guy, actually, David Maggott, is sometimes reminding me that, oh yeah. So, right. And so I think actually, to be 100% honest, I think the key thing that has actually happened is I was first doing assessments all by myself. My wife likes to joke that actually this was our baby that actually Neil birthed, not her. But eventually, and I was doing all the teacher training. And I was talking at the same speed and maybe stealing the mouse from teachers. And then I got this special grant that allowed me to do something. And the only person I could find that would be willing to work with me was my wife. And so she took over teacher training. She goes much slower. She does not steal the mouse from people. She teaches them one thing and then maybe they implement that. Not actually Dr. Heffernan, actually telling them about 18 different features, because I built a lot of features. There's this data-driven, actually did an instruction link that never panned out. Spent a lot of effort there. I've actually, we do have an automatic actually reassessment and retraining system that spaces out learning over time. That's pretty cool. But as we sit down and actually, we now give away assessments through actually Assessments 2.0, which is wicked slick and goes right into Google. And we are not actually we're actually not actually bringing over every feature that Neil Heffernan ever made. And luckily, we're actually having to throw away our old code and actually only bringing over the things that actually are really worthwhile to actually bring over. But that's largely based upon our opinions, just talking to teachers, and they tell us all sorts of things about what they like and don't like. And it's mostly by listening to these teachers. And every time I get to a classroom, I actually have so much fun because I actually get to hear all these little complaints, and then I come back to the lab and I'm charged up. I need to go fix this. I wish I could say that actually all the stuff we did for assessments is all driven by these wonderful randomized control trials I did, and we A/B tested every feature of assessments. It's not even remotely true. I wish I could say that. A lot of it is actually just by working with teachers one-on-one, getting feedback, and changing. You don't have enough resources to test every idea.
So it sounds like, you know, New England is where you've got the most penetration of assessments at this point. So I'm curious as to where you would assess assessments is on the adoption curve, if you know what I mean by adoption curve. That
like how easy
innovations start out, they're early adopters, early advocates, and then you've got kind of the folks that kind of follow along, and you've got the laggards. Where is assessments in that process? So
I think actually assessments for nightly homework is really easy, right? Like you're already giving homework. You're now just doing it this way. I told you 60% of teachers then actually also did skill builders, but not every of them, right? Then if you actually ask how many of them actually use the automatic reassessment and retraining system, or how many of them use the placements feature, or these other things that Neil Heffernan has also created, those are more. They need more. I think actually that MIT Poverty Action Lab was right when they were talking about a very low touch intervention, which is I think why lots of people were still using it, because at least the base product is dumb and simple. It's a dumb platform that allows teachers to make sure kids get feedback as they go. The fancier stuff like the skill builders, actually teachers lose a little bit of control, and they might not have good routines, classroom routines that allow them to figure out how to use that in a way that they can make sense out of. And so the more we actually have to change their classroom routine, the harder it is for people to decide to adopt. The hardest thing is write your own content, right? So we have a builder, they can write their own stuff, and that's like way at the far end of the adoption spectrum. Oh, and then there's the Crystal Siege. Not only write your own questions, but write your own feedback, right? Yeah.
So relating to that, I'm wondering how this is affecting how teachers spend their time. Like, are they spending more time on their homework or less time reviewing homework? Is this really a sneaky way to get teachers spend their free time writing assessment feedback? So you're taking time away from them? How would you characterize it?
Yeah. So I think sometimes people are shocked. Homework review still takes the same amount of time. We did not, you might think, hey, if all the kids got feedback the night before, teachers shouldn't go over homework. That's not what they decided to do, and it's not what we told them to do. Because when kids are making common or wrong answers, and lots of people are screwing up, you should talk about that. We did reliably modify that 8 minutes or so at the beginning of the period that actually teachers, of course, every teacher is different how much time they spend going over homework, but we did reliably get them to actually focus on a smaller number of questions and look at common wrong answers. And I think that's probably a more efficient use of their time. I don't think I think we actually take no extra time for teachers. Teachers already actually have to go, announce what the homework is. And as long as we make it wicked easy for them to actually assign homework. So if I'm a teacher using, say, Open Up Resources, and I'm a 7th grade teacher, and I want to do Unit 1, and I want to actually go do this lesson, I actually now have to, I can either say I want to assign all of these, or they can actually pick and say, I don't want to assign this one. And then I hit the button saying Assign to Google Classroom. So I just made an assignment, right? Like, it's that easy. And by the way, 10 years ago, it wasn't that easy. They had to click a billion buttons. And so we have about 30 teachers that actually make accounts every week. I still don't know what % of those teachers turn into real assessment users. We're hoping with our Assessments 2.1, well, one is we're hoping to actually track that better. And in the next few weeks, I'm hoping that we will actually be able to say, yep, our funnel is actually catching 5% of our teachers or 10% of our teachers. It's not 100%. And we need to make our funnel, open it up and actually make it easier and easier. And some of that isn't like fancy artificial intelligence. It's just dumb, stupid user interface design. Like, I shouldn't call it dumb. It's like just good interface design. It seems really important.
How are schools and districts using the data that that Assessments is collecting?
So most teachers, most of the time, we're just actually some teacher finds out about us and just uses it. So the data, it's not a district-wide thing. In Maine and in North Carolina, we have these studies, and the principals are kind of excited about it. Like the curriculum directors who are trying to actually implement, say, illustrative mathematics, I've talked to some of them, and they're like, ooh, now with this, we actually can better support actually our teachers, because if we have multiple teachers actually in the same building, and we can realize at our math department meetings, we can actually talk and actually ask, hey, Susie, why is it Miss Smith, why is it that actually none of your kids are making that common or wrong answer? What did you do? Because the rest of us are screwing that up. Like our kids, and then she might say, oh, the little lesson I do is I do this. Andrew Burnett was one of these guys that would sing songs. The X stands up, right up, down, and the Y is on the ground. He's got some gimmick. Maybe that could be shared and helps actually solve those problems.
Great. So you're talking about Assessments 2.0. These systems are always a work in progress. What do you imagine for Assessments 3.0?
Well, I can say that one thing is this 2.0 is actually being funded by a major philanthropy, and we just got $1 million to create a nonprofit actually foundation. And there's a press release that will be coming out soon, and then philanthropy will be named. But actually, we are trying to do what Khan Academy did: give away a free service and add what I'd think of just make it slightly less dumb over time. I want to continue the big free thing. I want to continue to be able to crowdsource from people, and that's what my wife and I are going to die trying. I do know that the natural language processing stuff that we're getting into is kind of actually fun. And so Dr. Heffernan, I pay the bills with things like where we're trying to actually do automated essay grading and then to be able to give teachers feedback actually for stuff like that. Maybe that will maybe grow in importance. We have all these open-ended questions that we don't give actually useful feedback to. We just say, thank you very much. But if we could actually give teachers comments to give to their kids, that could be really helpful.
Okay, well, we're out of time. Thanks, Neil. Great talk. Great work that you guys are doing. Very exciting. So our next webinar is going to be the last one in the series for the year. I'm going to be pulling together what we've learned from this whole series of webinars to talk about what are the different roles that AI can play. I call it the Magnificent Seven. 7 roles that AI can play in learning. And we've seen a number of these roles in Neil's talk today. So I hope you will join us. Until then, signing off. Thanks, Neil. Thanks, everybody.
Thank you, Louis.